is happening? So, in this question, I ask what is the function of the flux in submerged welding to completely cover the welding region, to prevent oxidation of joint, to prevent spattering, all of this, of course. So, D is true. There is nothing to explain over here. Then I say submerged welding can be characterized by high deposition rate. Yes. Slag shield resulting in slower cooling rate. Yes. Bonded flux containing metallic deoxidizers. Yes. So here also option D is true. Then I say UCS of a welding structure was found to be 30, which is more than 25. What does it actually signify? So if this is more than 25, what does it signify? I'll say there will be more concentration of construction strength. You know? If it is less than 25, it will be less chance of cracking susceptibility. So if this is more than 30, I will say more concentration of construction strength, more chance of solidification cracking, right? So A and D are true. Whenever your UCS is less than 25, that is a better joint, or the chances of solidification cracking or chances of this construction strain generation will be much lower compared to whenever it will be higher than 25. Okay. So what else do we have? We have those welding defects. Or how can we inspect those welding defects? There are a lot many defects as such, right? So I will try to cover those different defects. So what are the defects we have come across in our lecture video? We have come across something called undercut. What is undercut? So if there is some kind of groove kind of thing that will be cut at the toe of your weld, which will left unfilled, so that will be a undercut. So it will look something like this. It will look something like this. So this is my weld metal, and this is the reason when my undercut has been generated. Enough. So why this is happening? This can happen due to high welding current. This can happen due to larger arc length. uh, And how can you repair that? You can weld with some smaller electrode or doing some preheating kind of thing, right? So this is something called undercut. Then there are some defects called insufficient filling. So if your weld deposition is not proper, if it is not filling the space where you want to deposit, uh, that kind of defect below the adjacent surface of the workpiece material, that may happen, right? So improper welding technique or improper parameters can result in your insufficient filling of that weld metal. And how can you prevent that? How can you prevent that? You apply proper welding techniques. That's it, really. Then you can have some kind of misalignment, in your weld joint, right? Uh, Misalignment in the sense, so let's say you can have some kind of unsymmetric weld unity. So this is my misalignment in the Z direction, right? So this is my misalignment. You can have some angular misalignment. You can have some angular misalignment, you know. So this is mainly due to some, we would say this will be mainly due to if the, again, if you're not choosing your parameter or if you're not clamping your welding region, there can be those distortion, angular distortion or lateral distortions and those aspects. And how we can remove that? Basically, if there is any high amount of misalignment, that cannot be repaired, but a less amount of misalignment can be repaired by this grinding operation. You can do grinding and then make it proper, right? Then you can have some excessive convexity, excessive concavity, due to some change in welding current or travel speed, right? So depending on your welding current, you can deposit so many metals so that there will be this convexity in your weld metal. So if, let me make it 2D, so there will be convexity of weld metal. There can be concavity, right? There can be concavity of weld metal. So it all depends on what is your weld parameter, what current you are using, what voltage you are using. Uh, then what is your travel speed, welding speed?